Locating public exploits. In this module, we'll focus on various online resources that host exploits for publicly known vulnerabilities. We'll also inspect offline tools available in Kali that contain locally hosted exploits. A word of caution. It's important to understand that by downloading and running public exploits, we can greatly endanger any system which runs that code. With that in mind, we need to carefully read and understand the code before execution to ensure no negative effects. Take, for example, OpenOwn, which was published as a remote exploit for SSH. While reading the source code, we noticed that it was asking for root privileges, which was immediately suspicious. Further examination of the payload revealed an interesting jump code array. Although it was masked as shellcode, the jump code character array was in fact a hex-encoded string containing a malicious shell command. This single command would effectively wipe out the attacker's Unix-based file system. In the lines that followed, the program would connect to a public IRC server to announce the user's idiocy to the world, making this an extremely dangerous and potentially embarrassing malicious exploit. So if the internet is riddled with harmful exploits, where can we find reliable ones? The online resources mentioned in this module analyze the submitted exploit code before hosting it online. Nevertheless, even when using these trusted resources, it's important to properly read the code to get a rough idea of what it will do upon execution. Even if you don't consider yourself a programmer, this is a great way to improve your code reading skills and may even save you some embarrassment one day. Searching for exploits. After the information gathering and enumeration stages of a penetration test, we can cross-check discovered software for known vulnerabilities in an attempt to find published exploits for those vulnerabilities. Online exploit resources. Various online resources host exploit code and make it available to the public for free. In this section, we'll cover the 3 most popular online resources. These sites usually conduct tests on the submitted exploit code and remove any that are deemed fake or malicious. The Exploit Database. The Exploit Database is a project maintained by Offensive Security. It's a free archive of public exploits that are gathered through submissions, mailing lists, and public resources. The exploit database was designed to allow users to quickly find the information they're looking for. We can easily filter by type, platform, author, port, and tag. In contrast to other online resources, the exploit database occasionally provides the installer for the vulnerable version of the software for research purposes. When the installer is available, it's marked with a download box icon displayed in the A column. Another useful feature of the exploit database is that it indicates which exploits are known to be valid. These entries are indicated with a check mark in the V column. The filters for type, platform, and author can also be applied by selecting them in the table itself. To see all the information for a particular exploit, we simply click the exploit title. On the individual exploit pages, we can review all available metadata and the content of the exploit itself. When we return back to the main page, our filters are still applied. To return to the default dataset, we click the Reset All button. Exploit database updates are announced through the Twitter and RSS feeds. Security Focus Exploit Archives. The Security Focus Exploit Archives website was created in 1999 and focuses on some key areas important to the security community. These areas include the Bug Track mailing list and the Security Focus Vulnerability Database. Security Focus is a vulnerability database as opposed to an exploit database, so many of its entries do not include proof of concept code. However, each entry contains external references. These references can provide a great deal of information regarding the vulnerability and often include proof of concept code. Security Focus announces updates through their Twitter feed, and an RSS feed is available as well. PacketStorm. PacketStorm was established in 1998. It provides up-to-date security news, and as with the exploit database and Security Focus, also posts information about exploits and vulnerabilities. A key differentiator of PacketStorm is that it also hosts security tools. These tools are often tailored to a specific vulnerability or scenario and can be very useful. As with the other resources we've covered, PacketStorm posts updates to Twitter and also publishes an RSS feed. Google search operators. In addition to the individual websites that we've covered, we can search for additional exploit hosting sites using traditional search engines. We can begin by searching for a specific software and version, followed by the exploit keyword, and include various search operators, like those used by the Google search engine, to narrow our search. Mastering these advanced operators can help us tailor our search results to find exactly what we're looking for. As an example, we can use the following search query to locate vulnerabilities affecting the Microsoft Edge browser and limit the results to only those exploits that are hosted on the exploit database website. Other search operators that can be used to fine-tune our searches include in URL, in text, and in title. With just a few iterative searches, we're able to rapidly narrow down our results. As a gentle reminder, always use extreme caution when using exploits from non-curated resources. Offline exploit resources. Access to the internet is not always guaranteed during a penetration test. In cases where the assessment takes place in an isolated environment, the Kali Linux distribution comes with various tools that provide offline access to exploits. Searchsploit. The exploit database provides a downloadable archived copy of all hosted exploit code. This archive is included by default in Kali in the Exploit1 package. We recommend that you update the package before any assessment in order to ensure that you have the latest exploits. As with any other package, this is done using the apt utility. The Exploit1 package stores its copy of the database in the user share exploit1 directory. This directory is split into two major sections, exploits and shellcodes. The exploits directory is further divided into separate directories for each operating system, architecture, and scripting language. Manually searching the exploit database is by no means ideal, especially given the large quantity of exploits in the archive. This is where the searchsploit utility comes in handy. To display its usage, we simply run searchsploit from the command line without any parameters. As the built-in examples reveal, searchsploit allows us to search through the entire archive and display results based on various search terms provided as arguments. The options allow us to narrow our search, change the output format, update the database, and more. Finally, the Notes section of the Help menu reveals helpful search tips. For example, we can search for all available remote exploits that target the SMB service on the Windows operating system with this syntax. Searchsploit returns the results in a table containing the exploit title and the path to its location on the file system. Nmap NSE scripts. Nmap is one of the most popular tools for enumeration. One very powerful feature includes the Nmap scripting engine, which introduces the ability to automate various tasks using scripts. The Nmap scripting engine comes with a variety of scripts to enumerate, brute force, fuzz, detect, and exploit services. A complete list of the scripts provided by the Nmap scripting engine can be found under User, Share, Nmap, Scripts. Using grep to quickly search the NSE scripts for the word exploits returns a number of results. We can list information on specific NSE scripts by running nmap with the script-help option, followed by the script file name. This provides information about the vulnerability and external information resources. The Browser Exploitation Framework, BEEF. The Browser Exploitation Framework is a penetration testing tool focused on client-side attacks executed within a web browser. Needless to say, it includes a plethora of exploits. To list the available exploits, we must first start the required services. We can do this automatically in Kali Linux using the beef-xss command. Once Beef has started, we can log into the framework with our web browser. Now that we're logged in, we need to hook a victim browser. Since advanced hooking is outside the scope of this particular module, we'll just use the demo page provided by the framework by clicking the highlighted demo page link. This will allow Beef to hook our browser. Once our browser is hooked, it will appear in the Hooked Browsers panel of the Beef console as the localhost IP address. Clicking our IP, now known as a zombie, presents us with a new page containing details about our victim browser. We can then proceed to the Commands tab, where we can find various enumeration scripts and exploits. The Beef project is frequently updated with new features and exploits and is well worth experimenting with. The Metasploit framework. Metasploit is an excellent framework built to assist in the development and execution of exploits. This framework is available in Kali Linux by default and can be started with the msf console command. We'll cover this framework extensively in another module, but for now, we'll simply focus on listing the exploits available within the framework with the search command. To demonstrate, consider this search for the popular MS-08-067 vulnerability. Metasploit's search command includes numerous keywords to help us find a particular exploit. To list all the available options, we can run search with the -h command. Metasploit allows us to search by CVE, type, platform, exploit database ID, and much more. Putting it all together. With all of the primary resources covered, let's demonstrate how this would look in a real-world scenario. We're going to attack our dedicated Linux client, which is hosting an application that is vulnerable to a public exploit. We begin our enumeration process by running nmap to determine what services the machine has exposed to the network. This nmap scan will scan all TCP ports, perform version detection with very verbose output, and display only open ports and the reason for the port state. Based on the output of our scan, it appears that the system is running an SSH server on TCP port 22 and various services noted as James. Using Google to get more information on what the James services are leads us to believe that our target is running Apache James. In order to locate any available exploits, we'll use the searchsploit tool. Among the results, it appears that one of the exploits is targeting the specific Apache James server version that's running on our target system. A quick glance at this exploit shows that it takes the IP address as an argument and executes a specific command as root defined in the payload variable. Now that we've located our exploit, we'll attempt to run it against our dedicated Linux client without any modifications. The exploit appears to have worked without any errors, and it informs us that the payload will be executed once a user logs into the machine. We'll connect to our dedicated Linux client to simulate a login that would normally occur from the victim. After we authenticate, we get additional clutter from the exploit that would not occur during a standard login session. If everything worked according to plan, we should see a proof.txt file under the /root directory. Very nice. It looks like the exploit was successful. Wrapping up. In this module, we discuss the risks associated with running code written by untrusted authors. We also covered various online resources that host exploit code for publicly known vulnerabilities, as well as offline resources that do not require an internet connection. Finally, we covered a scenario that shows how such online resources can be used to find public exploits for software versions discovered during the enumeration phase of a target.